So TJ, when you're writing this down, when we talked about tangent, I gave you guys this information. This is something we found. So now I want to be able to look at, well, what about the cotangent function? Now, remember that cotangent, when we found these values, to find those values, we knew that the tangent of theta represented when a point on the unit circle was y over x. Now, understanding that cotangent of theta is going to be x over y. So really, what we have is just the reciprocal of these points. OK? So if we're looking at the reciprocal, and one thing we can go ahead and have, think about this. If this is 0, if you're looking at your points on the unit circle, this would have been 0 over 1. So the reciprocal of that for cotangent, so you could say the cotangent of 0 is now going to be undefined, right? Because if you reciprocate that to 1 over 0, now it's going to be undefined. Does everybody see how that would be the difference, how that would change that point? So now pi over 4. Well, the reciprocal of 1, this would have been, remember, this we got this point by square root of 2 over 2 divided by square root of 2 over 2. The reciprocal of that for cotangent of pi over 4, that's still 1. If you just flip those square root of 2 over 2 and flip those, you're still going to have 1. So that's not going to make a difference. Undefined, the reason why we had undefined for tangent, because it was 1 over 0. So if we take the reciprocal of that, now the cotangent of pi halves is going to be 0. All right? So now I'm just going to continue the rest of these, all right, going over this. So now you could say the cotangent of 3 pi over 4, that's still going to be -1. This cotangent of pi is now going to be undefined. Cotangent of pi over 4, 5 pi over 4 is still going to be 1. And the tangent, or the cotangent of 3 pi over 2 is now going to be equal to 0. All right? So let's go and graph these and see what they look like. So if we go and graph these points at cotangent of 0, we're undefined. What that means, undefined, we have a nice little asymptote there, right? So our graph does not have a point on the y-axis, the cotangent graph. Then let's go and take a look at the next point, which would be pi over 4. At pi over 4, we have a point of 1. At pi halves, we have a point of 0. And at 3 pi over 4, we have a point of -1. And at pi, we have a point of undefined. All right, so I'm only going to do one period for this, just to kind of keep this video a little bit shorter. But what you guys can see, again, if I need to connect these, and it needs to approach each one of my asymptotes, you guys can see that each one of these points is now correlated to what we had over here. And obviously, we can replicate this in the negative side of our x-axis as well. All right, but notice the difference on tangent and cotangent. Cotangent went down and up, right? And it intersected at the origin. The cotangent goes up to down, and it intersects at pi halves. Notice the period. How long does it take for this graph to repeat itself? Right? The distance is only pi. Remember when we were trying to find the period was pi divided by b? So that will change if you have a b. But we don't have a b in this case, because remember the b comes from right there. So we don't have a b in this case to go through. And notice, guys, again, for my class, the only thing I'm going to be concerned about is the important points, which is the x-intercept and the asymptote. So that's why we're only going to take this period and divide it by 2. So we just know where those 2 important points are. I'm not going to be too concerned about these other 2, how the graph affects. We'll talk about how it's going to be affected, but that's really about it. OK? All right. So what I am going to do